Hello all, this is Major Ben Bonifant, and today I'm going to be talking to you about data analytics. In this lesson, we're going to have two learning objectives. We're going to analyze data sets to identify key relationships and trends. And we're going to choose effective means to illustrate the data story to support data-driven decision making. First up, we're going to define our terms. Data sets are raw facts, information, and statistics that are compiled into a file. Relationships are the rate that two variables can change together. Key relationships are variables with covariance that impact trends. Trends are data over time that can be predictive. And then for illustrate, here are some examples of charts that can be used. Now I'm going to define data analysis, which is the process of collecting and examining statistical information and drawing conclusions from it. It is also the use of statistical analysis, visualization, and advanced computing capabilities to make critical decisions in real time based on available data. Here is the data science roadmap. We're going to start off with framing the problem. Then we're going to go to understand the data, then to extract features. The next step is to model and analyze. After you model and analyze, you have a few options. You can present your results if you're ready. If you found outliers or errors with your data, then you can deploy code to improve your data set and models. Or if you found outliers and errors to the point where the problem no longer fits, then you can go back to frame the problem and start the process over again. So if the problem turns out to be something different, then maybe you need to go back and start all over. Sometimes data can lead you down that way. For the different levels of FM certification, there are different things that are focused on within the data science roadmap. Level 1 focuses more on the data itself and the features. Level 2 goes towards modeling and analyzing, as well as presenting the results. While level 3 is going to be more focused on framing the problem and then presenting the results. There are two types of data with 4 levels of management. The two types of data are qualitative data and quantitative data. Within qualitative data, you have nominal and ordinal. Within quantitative data, you have interval and ratio. For nominal, there's no meaningful order to each, and each data point is mutually exclusive. Within ordinal, it is rank ordered, and the difference between the values is also unknown. Within interval, the difference between the numbers is meaningful, but the zero value is arbitrary. While in ratio, it is similar to interval, but the zero is an absence of something. So now I'm going to give you a few examples of each. So for nominal, we just have a list of universities. It's not telling us anything about what's different between them. It's just the list. That's all it is. For ordinal, we're going to give some numbers and an order to that list of universities. But again, it's not telling us anything other than a ranked order. When we go to interval, if we're looking at temperature, we can see that the measurement between all of the different Fahrenheit ticks or the Celsius ticks, they mean something. There's a difference between the 50 and the 20 because of how far they are from each other, and the different ticks mean something that you can truly measure. But the zero itself is just another tick on this line, which is different from ratio, where the zero means there's an absence. So with this one, there's an absence of speed. Speed just isn't there when we're talking about miles per hour. But if we were to go back to the temperature's still there, it's just at zero. So there's the difference of whether the zero is just another tick on the line, or if it actually means it's not present at all. So now we're going to talk about the 4 different types of analysis, also known as the 4 reasons for analysis. Descriptive is what does the data look like? For diagnostic, what is causing the data to be this way? Predictive, do I know what the data will look like later? And prescriptive, how can I improve the outcome? And now here are the 3 tools of data analysis. You've got descriptive statistics, probability and risk, and inferential statistics. We're going to start off with descriptive statistics, which allow us to summarize large amounts of raw data into meaningful information. Or it allows us to describe the data set. So we're going to go over a quick exercise, and we're going to start off with the measures of central tendency. And then we're going to go into the measures of variability. So here is our data set. We're going to start off with mean, or also known as the average. And the way we're going to calculate the average is we're going to add all of the different data points up and then divide by the number of data points. So here's our data. We're going to add all of these data points up and then divide by the number of data points that we have. And we get 186.18. Then we've got the median. When we calculate out the median, we find that it is 167. Next up, we have the mode. And the way that we find the mode is we're looking for the number that has it's seen the most. So we're going to find quite a lot of this number. If we go to our data set, we look at our data, we can see that there are 3 170s, and there they are on the graph. So 170 is our mode. Now we're going to go over the minimum, the maximum, and then the range. So if we look at our graph, it's pretty easy to find our maximum. It might be harder to find our minimum using the graph, but if we go through our data set, we can see that the minimum is going to be 152, and on the graph it'll be right there. And while we're using the max and the min, we can then find our range. So you would subtract the minimum away from the max. So some more descriptive statistics is the standard deviation. Here's some information about that. If we delve more into the standard deviation, we find out that 68% of observations are normally within 1 standard deviation. 95% of observations are within 2 standard deviations, and 99.7% of observations are within 3 standard deviations. And this only applies to data that is normally distributed. If it's not normalized data, then these standard deviations aren't going to work. So if we think about standard deviations and we look at our max, there might be an issue and it might be skewing some of our future models or how we're going to try to look at the data in the future because of how far away it is from the rest of the grouping. And we would call that a skewed data point. Next up, we're going to go over probability. Probability is the likelihood of an event occurring. And the way it is set up mathematically is between 0 and 1. 0 being impossible and 1 being certain. So if we have a scale here, you've got a 1 in 6 chance, you've got a 50-50 chance, and then this one shows a 4 out of 5, And those are just some examples that we can use for going from the 0 to the 1. First step, unconditional probability is the probability of an event occurring irrespective of other conditions. So think of flipping 2 coins at once. One coin flip is not going to impact the second coin flip. So we're going to start with, if it's heads or if it's tails, that's going to give us 50 and 50. And then the next coin flip, it could either be heads or tails, heads or tails. So the 50 and the 50 are further broken out into 25, 25, 25, and 25. Now for conditional probability, we have a probability of event B occurring given that A has already occurred. So what is the probability of flipping 2 coins and both landing on heads? Given that 1 coin landed on heads earlier. So because we already know that coin 1 landed on heads, that's going to shrink ours to 50, and we're going to keep it to 50. So we no longer split off into 25s, we just stayed with 50%. Sorry about the build, that didn't build the way I wanted it to. So we have a discrete probability distribution, which is built very much like a normal distribution. And we also have a continuous probability distribution. These are just a sample of what they look like. For inferential statistics, it is the process of obtaining information about a larger group from the study of a smaller group. Some examples are political polls, audits, and experts recommend. So in the news, there's all these different political polls that they pull from, and they're not pulling from the whole population, they're pulling smaller sample groups and trying to get an idea of the whole population based on their smaller sample. Same goes for audits. And if you pull from experts, then you've got what you would hope is a more specific, detailed answer that gets at the question or the problem you want to get at based on those experts. What does it mean to make an inference? Inferences are used when trying to draw conclusions beyond the immediate data alone. It answers the questions, what should we do next? Or how can we generalize the data? Some of the outcomes of inferential statistics are projections or estimates, a confidence interval, and possibly a rejection of the hypothesis. So now we're going to look at population versus sample. For different sampling techniques, you have a simple random sampling, where each individual has an equal chance of being selected, and a stratified random sampling, where there are factors that might divide the population into subgroups, and the proportion of each group in the sample should try to represent the proportion of each group in the population. So if you know what the bigger population is, and you try to make your sample reflect the bigger population, you are trying to improve your results with your inferential statistics. Now we're going to talk about confidence intervals. They represent how good an estimate is. The larger the confidence interval, the more uncertain the estimate. And the example we're going to go over is customer wait times. So here we have a set of data that has different customers' wait times. So we're going to start off with our descriptive statistics of the max, the min. We're going to calculate the average and calculate the standard deviation. And then we want to use a 90% confidence interval. So that 90% is going to guide us to using 0.9 in our alpha calculation. So 90% is the 0.9, which gives us a 1 minus 0.9 equals 0.1. So our alpha is now 0.1. So then our confidence calculation down here in Excel, now we have all the different parts of it. We can plug in our alpha, our standard deviation, and then the size of the sample, and it will give us 3.9. With that 3.9, we're gonna then calculate out the range of our 90% confidence interval. So what this says is we are 90% confident that the interval 24.9 to 32.7 captures the true population average wait time. Or if you're trying to be a little bit more succinct with your leadership, you might want to say we are 90% confident that your customers are going to be waiting anywhere from 24.9 minutes to 32.7 minutes. And that is either too long or too short, and probably too long. So we want to try to increase our manpower and try to get those wait times down. Next up, we're going to go over regression analysis. It's just a very introductory portion. So we've got two variables, and this is the data that they've come up with. And this line is showing us a positive relationship. So then the two data points that we have, or the two variables that we have, are forest fires and ice cream sales. Well, you may not expect forest fires and ice cream sales to be so related to each other, but once you think about it, it may not be the forest fires and the ice cream sales themselves. It might be temperature that is influencing both the ice cream sales and the forest fires, and that's why it's a positive relationship for all of these different variables. So now we're going to go through the JFAM model, and we're going to try to connect it to the data science roadmap that we talked about a little bit earlier. Here's our JFAM, and here's our roadmap. We're going to start with framing the problem, and that's going to link directly to planning initiation. And then we've got understand the data and extract features. Those are both going to go with mission analysis. And then for model and analyze, and then present results or deploy code, those two can go into the courses of action comparison and evaluation, or they can also lead you back up to framing the problem if that's what needs to be done with your data set. If you have gone through the data and you found out that the real root of the problem is something else, then you need to start over and reframe the problem. But the way the roadmap is set up, if you can see, we're not linking anything to COA development or COA approval, because those are two portions of the advisory model that is human derived and human specific. The data and the models are not going to properly give you your COA development or your COA approval. You need to have that human aspect that can see what the models can't and what the data doesn't tell you. As with the temperature versus the ice cream or the forest fires, so you need to have a human element and a true understanding of what's going on, rather than just letting the data go with everything. So the human element is going to create your courses of action and be able to make the decision or the recommendation. So today I talked about data analytics. I talked about the two different data types, which are qualitative and quantitative. I talked about the 4 levels of measurement, which are nominal, ordinal, interval, and ratio. I talked about the 4 types of analysis, which are descriptive, diagnostic, predictive, and prescriptive. I talked about the 3 tools of data analysis, which are descriptive statistics, probability, and inferential statistics. And then I also connected everything of the statistics model to decision support. And I thank you for your attention.